Hello, and welcome to ChipReport.tv. I'm Chris Gamble of Chris Gamble's Analog Life and the Amp Hour Podcast, the only electronics podcast out there. This week we got a whole range of chips. Small, pretty affordable, kind of useful. So let's dive right in. First up, it's the A3918 from Allegro. This is this small DC motor controller, basically, and you can control it through PWM. Pretty standard. A lot of similar chips out there, but we're going to really win with this chip for smaller operation. We'll get to the package in a little bit. Low cost and low power. So what does it have? It's got, well, first what it's used for, right? It's meant for industries that are not like, you're not going to be driving huge robotics with this thing. You're not going to be, driving a Segway down the street. But if you're, turning a camera lens, right? If you're moving the camera lens back and forth, or what else they're saying? Cell phones, tiny cell phone cameras, battery-powered devices, very small things. But when you have those tiny motors, you're usually constrained by space and heat and everything else. So this chip is really going to be useful for that kind of thing. The interesting thing about this, and I'm not sure if this exists in other parts, is it's got a 2-bit control register. And so it's got 4 different modes. One is disabled, one is forward, one is reversed, and the interesting one is a brake function. So it'll actually gradually step down the control and, you actually reverse it. It's better than if you have a motor running, right, and you're running the motor really fast. You don't want to just snap it off. You want to step it down gradually. Well, this has a function where you turn on the correct bits, and it has a macro in there basically that does it for you. So what else does it have? It has overcurrent flags, so if you're driving too much current because of a short on your motor. A lot of different sleep modes. It's got the brake mode, like I mentioned. It's got synchronous rectification in case you have noise sensitivity in your system. You can sync it to your DC to DC converter, or you can just, or an ADC if you want to sync it to the right frequency, you know what to filter out. And it has thermal shutdown. And that's actually what I wanted to call out on this chip, because this chip is actually really similar to the DRV883X family that we've talked about in previous chip reports. So it's important because I wanted to call out Allegro because it's not like the most well-known company. They're really well-known for some of the relay controllers. And that's the chips that I've had experience with Allegro, is the relay controllers have a brilliant overcurrent, over temperature function, to the point where you could be driving so much current through a relay that this thing will heat up so much that it'll start to actually even move on the solder pad. Not so much that it'll actually disconnect, but I've seen it heat up so much where the chip starts to move. I mean, that's some pretty significant heat in there. But what it does is it scales it back proportionally so that you don't go over a certain power level, you don't burn up your chip, you don't let the blue smoke out. All of the things that you want to really make sure you're not doing when you're controlling motors or relays or anything else like that. So I think this is an interesting chip. It's going to be, comparable to the DRV family from TI. What else does it have? It has 2.5 volts input to up to a 9 volt input on the voltage, and then the output, it can output up to 1.5 amps, and you set the external sense resistor, so it has a lot of flexibility there as well. If it was built in, you'd be kind of limited by whatever it's optimized for. The packaging of this thing is a 16-pin QFN, so not the most solder friendly, but definitely size friendly. 3mm by 3mm by 0.75 millimeters. Price-wise, it's going to start about 70 cents, and once you get up into volume, it's going to drop into 50 cents or less, and it's actually available now. Next up is the AOC2403 from Alpha and Omega Semiconductor. So I need to do a little backtracking on last week. You may have noticed in the editing that I was really excited about enhancement mode N-type FETs, and I just kind of seemed like I'd never seen that before. Well, the thing is, I did a little editing magic, but what it really was is in my brain I got confused between N mode, depletion mode, and enhancement mode. Enhancement mode is actually pretty common. The depletion modes are much less common. Even harder to find these days is usually P-type. I mean, well, really the depletion modes are the hardest to find. But this is a P-type transistor. Everything's getting harder to find because N-type is going to be the majority of your applications in terms of DC to DC converters and simple turn on the FET, let the current go through kind of thing. So you don't see as many companies targeting that stuff. You're really going to see P-type and depletion mode FETs on a bunch more niche applications, right? amplifiers, analog signals moving through it. You don't really need P-type as much as you really need N-type because of how converters are being made and the availability of higher voltage and higher current parts in N-type. So that being said, Alpha and Omega Semiconductor have this new part, and it's a P-type. But the thing that's really fancy about this is the packaging, and that's what they're really calling out here. They call it chip scale packaging, which I talked about last week as well. But for FETs, it's even a little more different because heat is even more critical than maybe a micro that's in a chip scale package. This is actually a 1 millimeter by 1 millimeter by 0.3 millimeter 4-pin BGA package, and that's ridiculously small. That's like fleck of salt, kind of small. But the important thing is that this can still do quite a bit of current and power. I mean, you always have to watch your thermal resistance so that you don't burn it off the board or let the blue smoke out or anything like that. But this chip is a very decent P-type transistor, and so the rest comes down to the type of packaging and how much power it can handle and everything. So let's go over the resistor itself, or the transistor itself rather. This thing can do 2.5. Can do up to 20 volts VDS. A little, yeah. 20 volts VDS. So when it's off, and it can pass. Where is it? I think it was like 2 or 3. Oh no, it's 2 amps. Now, what we need to do here is remember with P-types, you're actually referring to everything backwards, right? So because of how P-types are used, your gate voltage is higher than your source voltage, right? Your VGS is always going to be given in a negative number. So I say 2 amps, but it's actually minus 2 amps because it's going upwards through the chip, right? You'll see it when it's in the when it's in the diagram. But the important thing is at 20 volts and 2 amps, it's not necessarily the most exciting P-type transistor that's out there, but the fact that it's so tiny and that you can still pass that much current through it is pretty impressive. Also important is the VDS, or sorry, the on resistance, the RDS on, right? That's a critical parameter that a lot of people look at with transistors. And in this one, at 2.5 volts or minus 2.5 volts on the gate, you're going to be able to do 100 milliohms. So that's pretty significant. So that means that 2 amps going through it at 100 milliohms, that is 0.2 volts developing across the drain to source. Minus 2 volts if you want to do convention again. But the other important thing is this actually activates at a very low threshold voltage on the gate. So it does 0.3 volt. It turns on, not fully on, but it turns on at 0.3 volts on the gate. What that really means is this can be used in a logic level application. So if you have a micro and you only have 2.5 volts on your I/O, you can still activate this P-type transistor. So P-type FET is going to be used in a lot of bipolar applications where you have a plus rail and a minus rail. And so that's kind of the application I was kind of putting this in. An AB type amplifier actually uses both P-type and N-type FETs because you need to go rail to rail. So this is really I'm personally targeting this kind of part towards that application. So say you need to amplify an audio signal, very small audio signals because this is still decently low power, or if you need to do any other kind of amplification, maybe you're doing a small power supply, or there's tons of amplifier applications out there, and I'm sure you can find one. Price isn't too bad either. 60 cents in low quantities, 20 cents when you start getting down to it. So again, not a bad price. And the only thing that I wanted to get to on this part is my only qualm with this is the press release. The press release says that this part is available immediately in production quantities with a 12-week lead time. What? So yeah, it's available immediately if you're willing to wait. So if that's not hurry up and wait, I don't know what is. Really not much else to say about this chip other than it's a P-type FET. It's not that spectacular. If you have a TO220 kind of package with the P-type FET, you're going to definitely see better specs. But this is going to get you out of a jam in space-constrained applications and even cost-constrained. It's a pretty decent price. So, check it out, put it in your toolbox, and let's move on. Next up is the TCA6418 from Texas Instruments. And this is a GPIO expander, which I started looking at this past week because I needed more I/O. And so that's really what this kind of chip is going to be good for. it's going to allow you to take a low I/O output. So say you have an 8-pin micro like a PIC12 does, right? That's a 8-pin micro, and it's going to allow you to expand the I/O. So maybe you only have 2 pins to do an I2C bus, but if you talk to this chip, then you can configure it to have 18 outputs, 18 inputs, or a mix of the two. That's really where it's useful. I mean, it's going to free up a lot of I/O pins if you're constrained, and because it's an I2C bus, you can have multiples of these on the bus, and you can really start to expand out. The I2C is addressable, so you can say, you know, number 1, you have 18 pins, do your thing, number 2, whatever, and you can really start to stack up the pins. This isn't the only chip that's out there. There's actually other ones out there. This is there's the Maxim Max 7300 and the NXP PCA9698, which I believe is a replacement chip for a Panasonic from back in the day. So this is going to be good for a lot of applications like key panels, high I/O count products, GPS, MP3 players. Wait a second, guys. This was actually called out on the top of the data sheet. They said GPS and MP3 players, but I'm like, how much does this thing cost? It costs $1.50 in volume, or $3 if you're buying it in low quantities. And all I could think is, who are you guys kidding? At $1.50, you're not putting this thing in a cell phone like they said. They said smartphones. You're not going to be putting this in any kind of consumer level device. You know, it's targeted toward those kind of applications, but you're not going to be putting in there because this thing's way too expensive for that. So what I'm thinking is this is good for when you're in a tight spot. You're going to have not enough pins available. You might have an I2C bus. You can throw this thing down and you instantly have a lot more pins. Now the one thing they do target is the key panels, and I think that's a really good use of this thing. It actually has a built-in capacitive sense and a built-in debounce, which is really useful for when you're doing signal capture, right? So you could have an 18-pin keypad, and once someone presses a button, it detects the key press, and if the key press happens more than once in every 50 microseconds, it ignores. That's what a debounce is. So it's built in. You don't need that on your micro because that can take up cycles on your microcontroller, and you can just have it output a digital output back to your micro, and it says, oh, someone's pressing a key now. Another important thing about that, this also has an interrupt pin because sometimes your micro is not paying attention to this. Again, with any kind of micro, you probably have interrupt service routines, right? But you want to have something that actually tells it, hey, I need to interrupt you now. So this thing has an output pin for an interrupt anytime one of the keys is pressed, and they're configured as inputs on this GPIO expander. What else does this thing have? It also has built-in ESD, so you don't need external diodes. It's only up to 2 kilovolts, but 2 kilovolts on the human body model. I've seen a lot of parts going up into 4 kilovolt range these days, but it should be pretty good for any kind of, you know, human interface type stuff. So again, with the button presses. The rails, 1.65 to 3.6 volt, and it has 3 microamps of idle current. Now on the drive current, you can actually output 10 milliamps of current, and it can accept minus 10 milliamps of, you know, incoming if you're using as a straight input from another device. So maybe you have a digital input, you know, another device that's inputting some kind of digital signal, this can detect it. It's all register based, so anytime there's an input, it's just gonna, you know, store that value in a register. It was a 0, now it's a 1. It throws the interrupt signal high, and now your micro or whatever else external knows to go read what that register is, and it's ready to go. This has a 1 megahertz fast plus mode. Now normally I2C is, in the standard mode, it's 100 kilohertz. In the fast mode, it's 400 kilohertz. This has an extended mode, it's fast plus, and it runs at a megahertz. And that's useful in case you really need to update your signals, either inputs or outputs, however they're configured, a little bit faster. So, you know, you're still going to be having a serial protocol, but now you can be flipping those bits at a megahertz. So it's about twice as fast, or a little bit more actually. So, you know, it's helpful when you're, you know, if you're running out of room on pins, you want to make sure you can flip them fast. The packaging is a WCSP, which is a 2x2 millimeter part, 0.4 millimeter pitch, so good luck with that. And I already told you the price, about $3 in low volumes from your favorite distributors like DigiKey, Mouser, Element 14, whoever you use. Anything else to say about this? Not really. It's useful. Again, another toolbox type component. You know, it's good to have when you run out of I/O. Last up is the RX21A series from Renesas. And the actual part number is a big old number that we like here, R5F521A, and then a bunch of packaging types. But this is a new part targeted towards the smart energy market, specifically in the smart meters. So the ones that you store or that are installed in your home, on your wall, tracking how much energy you're using. It's also going to be useful in an industrial market. You know, anytime you need power monitoring, you can usually use those parts in a range of industrial situations. And this thing is actually fancy because it's got a built-in 24-bit Delta Sigma, and it uses the RX200 series micro, or all the core stuff from Renesas. I've never really used Renesas parts before. You know, they have a very popular RX78 family. They're used in a lot of high volume consumer level stuff. So I've never played in that market. I've never used them before, but I know people who've used them and they seem to like them a lot. This thing has, you know, all the things that you'd expect in a micro, right? But most notable about it is the ADC itself. It's a 24-bit ADC, and then there's different versions you can get. You can get a 3-volt or 3-input, 4-input, or 7-channel input, and that actually is going into a mux that then goes into the ADC. It also has other peripherals on board, like 12-bit SAR ADC, which you can use for, you know, temperature monitoring or anything else like that. And it has a 10-bit DAC output, so you can use that to actually, you know, output DAC values, and you can control stuff with that thing. It has a 512K built-in flash, so you can dump your ADC data directly into that. And 512 is, you know, getting up there on the built-in microcontroller range. And that's good because at 24 bits, you're going to be generating quite a bit of data. So this thing can store quite a few readings. It's low power, you know, what isn't these days, but they also have an 8-bit and a 16-bit version of a 24. So it's an 8-bit and a 16-bit version of the micro, and then they also have those for a 24-bit ADC attached to that, and that's a Delta Sigma ADC. So you can get a 24-bit Delta Sigma ADC from Renesas, and then you can choose 8, 16, and now this is 32. And that's nice because then you can do more operations basically in a shorter time span. You can do more addressing and all the things that you get with a 32-bit micro. It also has a built-in IRDA3, and this is a standard for infrared communications. There's actually the Infrared Data Association. That's what IRDA stands for. It's a serial type communication layer, and it's all the physical layer stuff. And basically, this is going to allow you to do an easy output to an infrared device. And so, the reason I think they're doing this is because basically you can have a power man come out to a smart meter, flash a little IR controller at it, and actually talk to it. I'm pretty sure that's the use for it, but you can also use. I'm sure you can use it for other things as well. The chip itself has 5 serial outputs, so that's just one of them. Power-wise, this is about a milliamp per channel of ADC, so that's the 7-channel version will use 7 milliamps. And then about 10 milliamps based on the frequency, the top-level frequency that this thing can run at. It can run up to 50 megahertz, and it's about 0.2 milliamps per megahertz of operation. So there's other players out there, and this is actually quite a big market. It's really hot right now because, well, why? I looked at the census data for the United States, and I was thinking about, well, how many smart meters can there even be? So I looked up how many households there are. There's 100 million households in the United States alone. These guys, and really the market at large, they're targeting to have smart meters in 100 million households worldwide, but in the next 2 years. So you could see why all these chip vendors are really hopping on this kind of thing. So there's other ones out there. Toshiba has the TMPM061, that's a family, and that uses the Cortex M0. And then TI has an MSP430 core, and then it has an add-on F673X family. And basically those are just micro and then 24-bit ADC. So what does this mean for you? It means that we're getting cheaper 24-bit ADCs, and that's not a bad thing. This isn't the cheapest micro you're ever going to see. It's about $3 to $5 in volume, but it's going to be really great for you if you need to do any kind of data acquisition, or if you want to. I mean, if you want to measure power, it's obviously targeted towards that. But if you're doing any kind of measurement or any kind of low and slow measurement, right? 24-bit ADCs, you have to actually integrate for a while because it's a sigma delta, but you get this really nice, precise measurement. For all you hobbyists out there that need this 24-bit ADC and all the channel inputs and everything, this thing comes in a 64, 80, and 100-pin LQFP package. So not too bad to solder, and it should be, you know, pretty easy to use. It's not available till December of this year, but you can start seeing, you already see it on, you know, vendor websites with all their, you know, crazy, or distributor websites rather, with all their crazy pricing. So, you know, check it out. See if you can find an application for it. Temperature, power monitoring, anything like that. 24 bits are really going to help you out in this case. So, in holding with ChipReport.tv tradition, let's try and make a fake project. So, the weekly roundup. What do we have this week? We have a motor controller. We have a P-type FET. We have a GPIO expander. And we have a 24-bit ADC / microcontroller / family. So, what can we make with this? Well, I was thinking about power, right? Renesas makes it very clear that they want this to be in the smart meter market. So let's say you're a landlord, or even you're just being very stringent on yourself on how much power you want to use. So you can use the RX21A family to monitor your power. You have, you know, a transformer input to this thing, and basically you measure 24 bits, and you know, all right, at this point we hit how much power, we hit a kilowatt for the month, and that's the amount that we should be using. And basically, you know that you want to shut off the power at this point. You don't really want to shut it off, though. You just want to be notified of it. So, you hit a kilowatt of power. This thing's monitoring how much power you're using. And then you fly a little flag with a little motor controller. And then you use the P-type FET in conjunction with a small N-type FET. And you create a small AB-style amplifier. And then you have a keypad, which then you have to type in a code in order to continue using power for that month, either because you're a terrible landlord and you want to torture your tenants, or because you want to just be cognizant of how much power you've been using. So you type in a code, and you're allowed to keep using power for the rest of the month. Good luck with that one. That's all for this week. Please be sure to give us a thumbs up on YouTube, and be sure to subscribe on YouTube, or check us out over at ChipReport.tv. And I'm also happy to announce that we now have a forum. So forum.chipreport.tv, and you can go over and see all of the different parts that we've talked about in past weeks. All of the parts I've talked about today will have their own thread. So if you have any comments or any questions about them, you can talk to me and all the other viewers of ChipReport.tv, and we can have a nice little chat about all the parts we've been using. So head on over there, and see you next week.